Yeah, you're good. I'm good. All right, cool. So it's recording and the audio is on. Okay, so that should be it. All right, so I'm gonna edit. Okay, so let's go to Brightspace. Okay, so we are currently on week 8 of the semester. Okay, and we are now making it one of the biggest topics that's in the semester, which is firewalls. Okay, so today I'll go over that. We are looking at firewalls from various levels, right? So you have, of course, your ASA or the PICs that you guys are configuring for the project. So I'll kind of go over that high level today in the slides. Yeah, so remind me at the end of class, guys. If you want to meet with me. Yeah, so as I was saying, if we look at, you should all be seeing the Brightspace. We completed intrusion detection systems. This homework assignment is due on Thursday, right? So hopefully that. And then as you can see, we are starting this phase, which is mostly the firewall or related to the firewall, okay? There's several ways that you can think about firewalls. There's the ASA and the Linux commands of it. That's the term project, right? We can also think of how does a firewall work, and that's what is called seed firewalls. So so we'll be doing basically in C++, you know, we're going to go through some exercises related to firewalls. And then finally, we have a third installment of firewalls, which will be Iptables. Okay, and Iptables is just a generic Linux basically, and how Linux implements firewalls. We'll be using the Raspberry Pi for this, and you have the documentation. So my plan is actually to do the Raspberry after spring break. Okay, and then right now, today and next Tuesday, we'll start looking at the software version of firewalls, well, the seed labs basically. But also today, I want to go over some slides that I have, and basically because these are pertinent to the term project. Basically, as you can see, the term project, you have, you know, these documents, the ASA. Hopefully, you guys are using these. In particular, this one heavily. But you know, we'll talk about firewalls and the ASA, just a little bit of some of the information that you may not be aware of with regards to that device. Okay, so take a look. Okay, so these are the slides. As you can see, there's some kind of general description, and then I'll go some of the main ideas, some of the commands there. And then this is also the documentation. That's kind of helpful. The ASA ACLs in particular. So we'll download that as well. Okay, so I'll definitely talk about this one. This one's kind of interesting. The last part, so you guys, I think, are at this point ready for this part to start thinking about it because it's a little bit different in the approach that you're going to take for that one. That's just VPN Design Considerations. Okay, so I'll talk about that. All of this is really related to the term project, and the ASA project is mainly, it's things that I want you guys to be aware of and start anticipating, which you've probably seen the questions, but you haven't really started to look at it. Okay, so I'm going to minimize these three. So those are the slides. And then, as I said, here we have the documentation for the, I'm not sharing. Here we have the documentation for the Iptables Raspberry. This will all relate to Iptables, so we'll take a look at how those, there's a sequence of problems that we talk about, like port forwarding, et cetera, which should be a lot of fun, but it's more fun when you use something like a Raspberry, an actual little device, instead of a VM. So for this lab, you'll have to use the Raspberries that are in there, and then we have basically this document, which is the seed labs in a couple of problems that we will take a look at. So there's several types of firewalls here as well, such as proxy firewalls, and some of the code. So there's quite a bit here. So let's just start with the slides basically today and what's related to the term project. So let me start with this one. So I'm going to start this document. This one. All right, so as you can see, this is, as I said, I'm starting with just the term project, basically. So if you look, this diagram here is exactly the same thing that you guys were building in your network, right? It's literally the same one. You have only the switches are not being shown, but basically you have the router, right? And then you have the ASA, right? And then inside you have the internal network. This is the DMC area. This is the internet, right? So it's basically the exact same setup, same network, basically. Okay. So the need for firewalls, so the internet connectivity is essential. However, it creates a threat, right? So today, I'm just going to go over this kind of like let's start somewhere with firewalls as a topic. Some of these things you probably know already, right? But I'm just going to start with the slides here. So the internet is essential, but it creates some threats. So you need to protect your local area networks. So basically, the firewall is inserted between the premises network and the internet to establish a controlled link, right? And it can be a single computer or a set of two or more systems working together, right? So in our case, we have two devices actually, and if you notice, what is happening here is they both have rules. They both have what are called access control lists, or the rules that prevent traffic from going through. but this is just a reduced number of rules on the router, whereas here you have more rules. That's really what it comes down to at the end of the day. So firewall characteristics of the design goals: all traffic from the inside to the outside must pass through the firewall. Only authorized traffic as defined by the local security policy will be allowed to pass. Okay. Techniques used by firewalls to control access and enforce the site's security policy include looking at services, right? The port numbers, basically, the direction of the packets, right? So everything's allowed to go out, but things coming in are not allowed if they originate from the outside. It also can be used based on user control or some kind of a behavior of the packets as well. So basically, the firewalls are packet filters at the end of the day. They're sniffers, right? And applies rules to each incoming and outgoing IP packet. And it's typically a list of rules based on matches in the IP or TCP headers. Okay, it either forwards or discards the packet based on rules, rules matching. And that's really all it is. And it's like if statements, and then we're looking at the headers. So it's exactly the sniffing and spoofing that we've done before, right? And then we will see actually when we do one of the seed labs where we build, where we add rules in C++. And we will see actually that it's just if statements. We take apart the packet, we look for specific fields, and then we have to decide what we're going to do with the packet, drop it or allow it, etc. The filtering rules are based on information contained in a network packet. So these are going to be the usual source IP, destination IP, source and destination ports, IP protocol, the interface, etc. Now this is meant to be pretty fast, right? So a firewall actually is a device in between, right? That is really letting things through. In contrast with an intrusion detection system, which usually does not permit things or anything like that. It's more of an after the fact thing where it's just supposed to detect things and send out alerts. All right, and the reason being, if you remember, something like Snort, for instance, looked at the payload, if you remember, right? So it looked 50% of the rules in Snort actually were looking at payload. And so there is that that issue. Also, data is going to be encrypted, et cetera. So there are issues like that as well. So the advantages of a packet filter, of course, are simplicity, typically transparent to users, and are very fast. Okay. Weaknesses: it cannot prevent attacks that employ application-specific vulnerabilities for functions, right? Because it doesn't check at the application layer, payload, etc. And it could have limited logging functionality. So now you do have another more advanced thing called a stateful inspection firewall. So this tightens rules for TCP traffic by creating a directory of outbound TCP connections. So there's an entry for each currently established connection. Okay, the packet filter allows incoming traffic to high numbered ports only for those packets that fit the profile of one of the entries in the directory. So it's basically how it establishes a connection, and it just keeps a table. So traffic going out, for instance, will be populated in a table, and then when the packets come back in, they'll be allowed through. So reviews packet information, but also records information about TCP connections. And here's an example of this. So basically, you do the three-way handshake with some server maybe. The client is inside the network and it's going through the firewall. And if you can see, you have an established connection between this 76 IP and this 128. So you just keep track of it on the firewall. And firewalls can handle many of these connections. Sometimes this is how you measure the firewall, right? The capacity to be able to, how many of these can it handle, and so on. As you can see here, an attacker who initializes from the outside will not be allowed in through this type of approach. And then here you can see, this is just an example. It's a simple table that you have available. Okay. Host-based firewalls. So host-based firewalls are basically just a firewall on the computer. So you're all familiar with this. Your own Windows machines have firewalls, right? So they're basically used to secure an individual host. Available in operating systems or can be provided as an add-on package, as you know. Basically, the same idea. It filters and restricts packet flows. Okay, and you know, one of the advantages of it is that the protection is provided independent of the topology, so it is provided in that same device. Okay, and here you can have more specific rules to your environment. So one of the things that we will do this semester a lot is look at rules, or the rest of the semester, I should say, is look at rules, right? So just your Iptables lab has, I think, like 10 rules that you have to do. And then your CVM labs, the software one, has also several rules, you know, 5 to 10. And then also the ASA project has several rules as well. So ultimately, you should be exploring around 30 different types of ACL type rules. So it's a pretty good coverage, I think, as far as all the rules that we have to implement. And I know some of you have already even started with the ACLs on the project. Okay, so that's pretty important. Here's an example of the network configuration. One of the things about all these, I have several diagrams throughout these slides. And one of the things I kind of want you to always think is always go back to this classic design. You know what I mean? Because regardless of how complicated something is, you can always start to see this one, right? And so that's an important one. So look at this one here, right? It looks like that. And then we look at this one. And it might seem like it's a lot more complex, right? You look at it and, oh, whoa, that's a totally different one, maybe. But actually, it isn't. It's almost the exact same thing. If you look at this network, it's exactly similar. It's got, there is a boundary router, and then there's an external firewall, okay? And then there's a switch, and then there's an internal firewall. That's really the only thing. But it's basically the same idea. At the end of the day, what's the difference usually? One is more strict than the other. And we're going to talk about this as soon as we talk about something called domains of trust, you know, which is kind of a way of thinking about the design of this. But if you look, you have the boundary router, right, that's connected to your ISP. That goes to the internet. Then you have this external firewall, which is connected to the LAN. If you notice, this is the DMC, exactly the DMC, the demilitarized area. And basically that usually means the servers that need to be accessed from the outside, that you still want to have them somewhat covered, but they're not the internal network, right? So usually things like your web servers, there's going to be an external email server, DNS servers. Okay, these are the things that you can have outside, right? And for various operations. And then inside the network, the internal network, you have now, this is, you know, this you don't want anybody from the outside to come in unless they do that through VPN. Okay, VPN is one of those services that I will now start to hint at you because it's pretty interesting how we're gonna attempt to implement that through the GUI interface. So the configuration of VPN services actually through the command line can be quite complex. There's a lot of rules that go into making that happen. But I don't know if you guys are aware, your devices come with something called the ADSM, which is the GUI interface for the firewall. So what that means is you have to go in and do a command on the server, on the firewall, and do like enable HTTP server on that device with permissions, right? You have to grant permissions, and then through a computer, you'll be able then to connect to it. In the past, one problem with that was that it was written in Java, and you had to like deal with all the Java versions, right, for it to work. Because we have different firewalls now, we have a whole bunch of different firewalls with different versions. I'm guessing it's going to be different from each version. So one of the things that I recommend that you start kind of exploring in your device is the ADSM. Okay, I'll provide some basic commands that, you know, to kind of give you some guidance, but for the project, I would recommend that you start looking for the GUI interface of your device. Okay, GUI interface will allow you to configure the firewall completely without the need to use the CLI, but I would prefer that you use the CLI for everything except for VPN. All right, we'll talk about what I mean by that, but VPN services, it would be nice if you configure them, and the best way to configure them is through the GUI interface. Does that make sense, guys? We'll talk. I have some slides for that as well, but anyway, just throwing that. All right, so if we had a VPN, it would be one of these firewalls, right? Probably this one, because what you want when you do a firewall is you want to get an IP of the internal network, right? Usually it's not going to be the same domain or same range exactly. That it's going to be like a segmented range that you can use, but you would be able to reach to here, and then the VPN service on the, because the VPN service that we should use is going to be on the firewall itself. So firewalls of this caliber, they're not just the ACLs, they have other services like VPN built in. Okay, and that's pretty important, a pretty important one. So you would connect to the VPN service, get an IP, and then now you're surfing on inside the network. Okay, and there's a lot more to that we have to talk about, but we'll talk about that in a few other slides. Okay, and so now you're behind the firewall, you're in the switch, and as you can see, these are the worker workstations, the internal servers, whatever, finance, payroll, etc., that are important to your network. Okay. Any questions so far? Is all this making sense? Okay, so ingress and egress filtering. So you'll see in one of the labs, we'll have some exercises about ingress and egress. And also we're going to do some labs about how to evade firewall rules. So those are really fun because you're going to put in some ACL rules and traffic should not go through, right? But then you can evade them, right? And the trick to do that is we're going to create tunnels, right? Like SSH tunnels through the firewall and those kinds of things. And you guys have played with tunnels before, so we'll take a look at that. So that's kind of like egress, escaping, or ACL. But anyway, the terminology is ingress and egress filtering. So ingress traffic is coming into your network, and then egress is traffic leaving your network, basically. Firewalls have rules for incoming traffic. So something, kind of in pseudocode, block all in from IP. Okay, and then leaving traffic, block all out from IP. So you can see there is this flow, there's this direction in the commands that you can take a look at, right, of what you're going to allow in or out. Okay, so this is our, I usually just follow this like standard design, when I talk about what to motivate the lab. So you guys know, as far as the project at this point in the semester, you should set the devices, right? Set up interfaces and IPs on routers and firewalls, set up some kind of a network address translation. That's something that I want you to experience, right? And I provided the commands for most of you, except those that have like the 8.4 version of the firmware. So set up NAT at the routes. So we've talked about the routes, and I will talk about that today a little bit more. Configure services on web and DMC server, and then basically after that, once the network works, you start adding the rules and going through the cases. So this is really the lab. So these, when you look at the hints document, these are the commands. Usually for NAT, it's going to be these commands for everyone using the PICs or using the ASA up until firmware version 8.3. You should be good, and just creating with this command set of global NAT, and then as I said, the route, I'll talk about that. Then the interfaces command, so setting the interfaces, adding the IP addresses, and then there's a few other things I'll talk about, but these are some of the other commands. So network address translation. So I've mentioned that, and I think you guys, I'm sure know this, but I guess I should state it. So network address translation, translating private addresses to public addresses, right? And there are various types. So NAT, for instance, the basic NAT is a one-to-one NAT. And this is actually really the one that the hints basically says to use. So the internal IPs can correspond to outside IPs. So what that means is, if we go back to this, so that's why I have this. So you're a client at 10.0.1.2, but now you're going to go out to the internet, right? So you're going to send some traffic to 10.10.10.2. So when you go through a network address translation and you go through this firewall, what's going to happen is your source IP is going to be changed from 10.0.1.2 to something in the pool of network addresses. So for instance, you in the hints document, you set up a pool from 180, that could be 192.168.1.50 to 192.168.1.80, right? And so there you're setting up a pool of 30 IP addresses that have been allocated for network address translation services. And that means you have 30 available for one-to-one mapping. Do you guys see that? And so that's basically what network address translation is. That will be, of course, recorded in so that when the IP comes back, it'll be mapped correctly to the originating IP on the inside of the network itself. So that's usually called a one-to-one NAT. There's the PAT, right? You guys know what the PAT is? Port address translation, right? So you can use port numbers for that. All right, so these are some of the commands that you will see there. I'll probably go to the hints document as well, just to make sure that all of that is clear. You can try basically a command such as show xlate or something similar to view the mapping. Okay, so what I'm saying here is to view mapping commands. So when you are on the client and you open a browser to the outside computer, and then you run a command on the firewall itself, you would be able to see the mapping and say, yes, 10.0.1.2 has been mapped to maybe the first IP in the pool of the network address translation. Do you guys see that? So that's definitely a command to get in your global set. And then actually here, then you have the two commands, global and net, which are pretty consistent actually for the devices that we have, except, as I said, 8.4 or above. And I think we only have like 3 of those. So the commands are global and then net. So you can see here, actually, I have it here. So the idea is global sets the pool of IPs to use on the external side. This pool, so these are going to be the 192.168 IP addresses. So basically what you do is you'll see that in the hints document, it says global 1 and then a range with the net maps. The 1 means an ID. It's literally like you could do global 2, global 3, global 4. They're just IDs that you're setting up for different ranges. And then with the NAT command, you can create a rule that says any traffic from the inside going out, map it to this range. So global ID 1, right? And so that rule will also say something like NAT any, which is 0, 0 to 1. And so you create the mapping between anything in the inside to the range. So it's a rule that ties the internal IPs to the external pool via the ID. Does this make sense? Guys, in the virtual world, you're awfully quiet. Everyone clear there? Okay. All right. I don't know. So yeah, so these are the commands. So the NAT commands. And it's something that I want you to do as far as the lab, just so that you can see that. It's very nice to be able to see that mapping. Okay, so that's usually, I should say, that's usually a question I'm going to ask. Show me the mapping in some way between the internal IP and the outside IP. So that means your NAT needs to be set up. Okay. Okay, just a couple of things. Remember, you want to see your interfaces up, line protocol up. So this shows you that they're basically, and then you can see the inside is also up. So they should be connected. The router commands, I think all of you pretty much know how to do this, right? So same thing, that's in the handout. So just make sure you follow the instructions. And then there's a few other commands. So I think I've been asking a lot of you to just run show version. Make sure this is an important one, you know, given that we've, you know, received several of those devices over the years. They have different versions. So check your version. Let me know if you have, basically just let me know if you have anything above 8.4 or above. Other useful commands are show interface, displays the status of your devices. Show running config, it'll show you also configuration. Okay. Now this is an important one, so I'll go through this one. So the command structure, basically, right? So config T, enable, interface, and so on. So Cisco devices, this applies for the firewall and the routers, have different modes where where only certain things can be shown or certain things can be changed. Okay, being able to move between these modes is critical to successfully configuring the device. I should have said the device. So for example, when logging in, you start off at the user mode where the prompt might look something like this, right? So you're just kind of in that mode. From there, you type enable to move to a privilege mode where the prompt might look something like this. Okay, the privilege mode. In privilege mode, you can show anything, but you know, may not be able to make changes. So next, you need to type something like config T, right, or config terminal to go to global configuration mode, where now your prompt might look something like this. You see that? So you're changing between all these states. From here, you can change global parameters, and then to change parameters on an interface like the IP address, you go to the interface configuration mode with something like that, interface, and then it should look something like that, config if. Okay, so that's basically the transition between all the states in the devices. And then you have things like no shutdown. The no shutdown command enables an interface, basically brings it up. And it is useful for new interfaces and for troubleshooting. Show IP route. So this I need to talk about, the routes. So command is used to show the router's routing table. This is the list of all networks that the router can reach and how to get there. So you can see some commands here, but in particular, what I want to talk about. Oh, I'll do it with this. So when you configure, so the steps to enable, let's say the network, right? You're building the network. If you enable the interfaces on the router, basically it just starts to work. That's pretty much how it is. With the firewall, the sequence that I would recommend that you follow is, you know, configure the inside interface. Notice that usually the inside is the 1, because, you know, the I, and the outside is the 0, 1 because of the O, right? So that has been a convention, so you can check that out. So establish the interfaces, right? So set up the interfaces. Then once you have the interfaces, basically the network address translation would be the next step. Okay, and then after that, the last simple thing that you need to do before anything major is to set up the route command. And why do we need a route command? So think about this. We're not using any dynamic protocols, right? You're just setting up everything statically. We're also not using any networking. I'm not asking you to enable any discovery networking protocols, right? So what's going to happen? This ASA device only knows the 10.0.1.0 network and the 192.168.1.0 network, but it doesn't know other networks, right? Like, let's say that we were connected to the internet. If we were connected to the internet, how would this device know to get to Google's DNS server, 8.8.8.8, right? Or a more simpler version of that is, how does the firewall know to get to the 10.10.10.0 network? So what do you guys think? How could it learn that? Set a route, right? Which basically means you know, over the years, I've taught this class, I always see this one thing that students don't remember, and that is default gateways. That's a common mistake that I always see in the devices themselves, like client PC, DMC server, web server, or the devices like the firewall itself. Student, you know, there's always a little bit of confusion, right? So usually when you configure these statically, right, you're going to say, you know, this is 10.0.1.2, and then it's 255, 255, 255.0, right? But then there's also the option, you don't need a DNS, because if you notice, we're not doing anything with domains in this lab. So there's no need for DNS. I've also asked you not to do DHCP, because that could abstract a lot of the things that I kind of want you to actually manually do, right? But we're doing things statically. So one thing that you should tell the 10.0.1.2 is what is its default gateway. So its default gateway is actually 10.0.1.1 for this device. Do you guys see that? For this device, you could say it's 10.10.10.1, and for this device, 192.168.1.3, because you're not really going in that direction. So it would be 192.168.1.1. Do you guys see that? Now, there's one still, that's for the devices themselves, right? Like on Windows or whatever, you're doing that configuration, or in Linux. However, there's one more route that's really important, and that's the route of the ASA, which is what I was saying. If the ASA, let's say the client PC wants to go to 10.10.10.2, right? It sends the packet, it sends it here, and the firewall will say, well, I know the 10.0.1, I know the 192.168.1, but I don't know what to do when I have a 10.10.10.0 IP. So I don't know what to do, so I'm just going to drop it. And so that's why you also need a route command that is also in the hints document, right? We'll take a look at that in a second. But that routes command basically says, whenever you don't know where to send the packet, send it to your own default gateway. And what's your default gateway? The next hop, which is the router on the inside interface at 192.168.1.1. So then now with that rule in place, the packet will know, well, I don't know 10.10.10.2, because it could also be 8.8.8.8 or something like that. You know, you guys could have connected, you know, to this switch a Raspberry acting as a router, and then you have another network on the other end, right? You know, and so that's a fun thing that you can try. And so if I don't know that packet, well, my route says just send it over to 192.168.1.1. Then this router knows 10.10.10, and so it'll forward the packet. Does that make sense? So that's an important one that you should all be aware of. Any questions on this? So this is kind of the sequence. It should be the basic things that you have to do. These are the basic things that you have to do. So there's like three major things: this, the ACLs, and then the advanced services like VPN. Okay. Questions? Nope. All right. So we finished these slides, right? So let's take a look at the other set of slides. So to finish these. Yeah, so these ACLs and filters, right? So it's kind of like the second thing. So let me share. All right, so you should all be seeing this part now. So assuming that you have configured the device, right, by following the hints document, the hints document also starts getting into this part, okay, the ACL. So these are the access control list and filters that you can set up on the device itself. Okay. So before we get into ACLs and the rules, access control list, we are going to talk about something called the domains of trust, right? And this is just a nice little thing, a nice little concept, which basically looks at your network and you kind of divide it into segments, right? You know, just without just thinking of your operations in your network. And it basically goes from no trust to high trust. Basically what it means, like insecure and more secure, right? Of where things need to be more secure or less secure. So if you look here in the idea of domains of trust, obviously the most untrusted area would be the internet, right? Internet trust domain. Then after that, you would have the external servers, the public server trust domain. These are the publicly available servers. Then the wide area network, the trust domain, where you kind of get into start to get inside the network. And then you have internal servers, basic user trust domain, user PCs, and then even further, you have like your finance trust domain, payroll, that kind of thing, and finance server and finance PC. So the idea is, I guess, you break it down into these domains of trust, and then from there you learn to segment with the hardware itself. So you can see here we go from this diagram where we have the common domains of trust, into internet, public servers, all of them, to something like this. So you can see now the domains of trust, you start basically, choking the traffic basically. So like establishing points of control and access control in particular. So you can see here in this scenario, we have the exact lab that you're doing, or the project, right? The ASA project, same thing. There's the ASA. This is the router, the Cisco 2600. This is just a firewall, the ASA itself. And then here, basically, now you're just in the internal network. All right, you can have your user PCs, and then here you just choose to have an additional router or firewall. It could be the Raspberry or something like that, where you then segment out a more trusted area, like a data center or something like that. At the end of the day, the difference is you have more and more access controllers, right? You have more and more, you have fewer and fewer open ports. You have more and more restrictions. You have flow that only now, like here, flow usually can go in both directions. Here, as you start getting into this, it's a lot more restricted. Also remember, there's kind of this suggestion of, what is it? You guys help me with it, because I always get these words wrong, but explicitly denied, implicitly accepted. Implicit and explicit, right? So what's the right slogan there? Implicit deny, right? Implicit deny. And so the idea is that everything is actually not accepted through. And then you start adding exceptions to let some things through, right? So that's kind of the idea there. Okay, and so this, you can see here, this one domain, the domains of trust, basically, it basically looks a lot like ours here, right? With the router, the ASA, this is the internal network. So this simple internal network that we have over here can actually be, much more complex. So that could be all of this. You can add more devices in there, and so on. Okay. Any questions so far? Okay. Making sense? So here, just a little bit about the devices, the basic filtering routers. So this is pretty much what you have at home, right? At home, you really just have the ISP router, and that's your firewall as well, and that's everything. So basically, you don't. Okay. No, not this time. Yeah, so you have your basic ACLs there. Nothing is outside from the outside, correct? That should be that's your home scenario. Basic filtering router, easy to implement, least secure. If you had public servers, you would have to open ports, and that would be a bad thing, right? So the better solution for that would be VPN services, but then you have to set up VPN. Okay, so we'll talk about that. You can always have a VPN server inside, but you have to open a port. One of the labs that we will do this semester is port forwarding. So I'm sure you guys have heard of that, right? And that actually relates to this one, right? So if you want to access something inside your network, you will need to do port forwarding on the device on the outside, so that anything that you you're going to set up some port 4000, I think is usually what we do. So if you hit port 4000, any traffic there will be forwarded through the firewall to some specific machine inside your network, right? And that we'll talk about that. And we'll do that one in the context of Iptables, basically. So the Raspberry will help. It's easy to implement, but least secure. Public servers are on the internal side of the router. Compromised public server can attack internal systems, so that's definitely not something you want. It's a single point of access control failure, and it requires multiple open ports, which is not what you might want. Then this is the classic dual router DMC. This is pretty much what you're building in the lab. You know that this now the public servers are separated in another segment from the rest of the internal network. Usually that segment is referred classically as the DMZ or the demilitarized zone. Filtering, second router should have more restrictive ACLs. At the end of the day, that's it, right? This, if you have, let's say, two routers here, this just has basic ACLs, this has more restrictive ACLs. But these are two routers still, so flow is allowed in both directions. Usually port 80 will be open here, so you can access maybe your web servers over here, but port 80 will be closed on here. In fact, when you use the ADSM, which is the GUI interface for the ASA, you're only allowed to open it from the inside interface, not from the outside. Does that make sense? So that's an important concept there. And then this actually is the design we have. The firewall DMC design improves dual router DMC by allowing strong filtering between internal network and public servers and the internet. Can impact performance, but can impact performance, but that's why you spend a lot of money, right? So these are expensive firewalls, right? So they cost. They can cost thousands of dollars, and there's also the issue of license. You have to get a license. I think they charge you even for like number of users of VPN services and things like that. So they can get a little bit pricey. All right, but the idea is, here you have the ASAs. The ASAs that we have should support IDS, actually. They should support some heuristic rules, just like the snort rules. It has some built-in. If you want to get more rules, probably have to pay a license for that. There's VPN services, and they support a lot of VPN connections. One issue that you guys will have with the VPN is the VPN client. So what that means is, remember, when you're connecting with VPN, this will be a service that's set up, but you need to connect to it from a laptop, basically, right? You're going to be on switch 3 on the outside. You need to have a VPN client that's compatible with a VPN server. Do you guys see that? That's something to start thinking about. Okay, getting that VPN client so that you can make the connection. Does that make sense? Yep. All right. No, because actually that can be a problem sometimes. So just think about it. So anyway, yeah. So I was saying, this is the classic example. 2 interfaces. I think the Pixes only have 2 interfaces, but the ASAs have 4. I've seen. They even have a dedicated DMC interface. I think. I don't know if you guys have looked at that. And I think that's the next architecture, actually. Yeah, this one. See, where the firewall actually, you don't have to have it on the separate switch. There's actually another port on the device that could be the DMC, and it's another network, right? So not the 10, not the 192, but some other. And then you can put your public servers there, and then basically all the filtering is controlled by this. So the beauty of that is, of course, instead of just going through the router and going into that switch, now it also needs to go through the firewall. So there, in essence, there could be a little bit more security. Okay, I'm not asking you to implement this, but just be aware that that's another type. This is referred to as the 3-interface firewall design. Most common topology used today, considered best balance of security, cost, and management. Okay. So, and then, as I said, the advantage of it is all traffic must flow through the firewall itself. And then you have like, this is more, more expensive, I guess, but you might have a need for this when you have like something like, I guess, like e-commerce, something that is getting a lot of access from the outside, databases, etc. And so that this can be the so-called multi-firewall design, where you have public servers. Notice this is still the internal network. This is still the internet. You have the router for ISP connection. Then you have your more control devices, and you have some public servers on trusted, and these are more trusted basically. So usually the database, where in the databases, the idea is that users directly access the web server, but they should not be directly accessing the database. Instead, the web server accesses the database, right? The PHP code, etc. So you guys remember that from your PHP classes. So, and you can read through that explanation. All right, other types of firewalls. So as I said, we have some seed labs to cover other types of firewall, the proxy firewall or content filtering firewalls. So the ASA type of firewalls are mainly, as we discussed, like sniffers, IP, or TCP header kind of matching, right? That's basically the idea. We've looked at, whenever we want to look at higher levels of the protocol of the OSI model, the only thing we've looked at so far is intrusion detection, right? So in Snort, we were looking at payload, but Snort was not a firewall. It was, as I said, an after the fact, more of raising alerts rather than dropping packets. However, we can set up some firewalls that are higher level, much higher level. And so sometimes they are referred to as content filtering firewalls. This will actually be one of the lab assignments that we do later. I don't know when we'll do it, but so this lab is, we'll just like we use Snort for IDS, we will use something called Squid for content filtering firewall. The way this works is exactly, it's similar to Snort. We're going to set up in our network a server, right? Which in this case would be Linux, of course. We're going to turn on Squid, and the Squid service then would be our content filtering firewall. So what we have to do is we have to now tell all the clients, we can go into the configurations and tell all the clients, for instance, this is an example. If you want to go to the internet, you now have to go through a proxy first. Do you guys see that? So you have to go through a specific device called a proxy. So all packets, before they flow in and out of the internet, they must flow through this server. And what the server does is it's going to check the content of the packet in a more higher level, not just like the ASA would, but a higher level. And if this can also block as well. So that's going to be the lab that you're going to do. So you can block Facebook, you can block, so companies may want to block Facebook, right? For whatever reason, because it's such a great thing, right? So who would want to block it? Right? So, but they may want to block it. So then they would say to all these devices, then the browser would need to be configured in such a way that whenever the traffic is leaving the network, before it leaves, let's say that printer is the proxy, so it has to go through it, get filtered before it goes out or not. All right, so content filtering design supports applications that don't work with traditional access control or the ACLs, right? So not Iptables, not Cisco ACLs, and so on. So we'll do this. This is definitely a lab that we will do at some point. So here's the content filtering design, actually. So I forgot I had this. So we have here the internal network, right? So this is your client PCs connected in the network. This is the ASA. This is the router, the internet, switch 3. But before they go out, they need to go through this, right? And you have to think about where you're going to position the device. Here, it just happens to be on the DMZ area. It could be on the internal network. There's no reason why it couldn't. The devices they just know that before they go anywhere, they must go to this IP address. Do you guys see that? Does this make sense? So that's the content. And just remember, this will be the SQUID lab assignment that we will take a look at. All right, so now that we've talked a little bit about that, basic filters and ACLs. So in the past, you had things like rules specific for ICMP or something called conduit or outbounds, etc. So Cisco it's always changing, like, or consolidating. And I think a lot of it has to do with the fact that they buy other companies. So they buy other companies. The companies have had a specific way of doing things, and they've integrated the devices over time, right? So, but anyway, usually it's going to be this idea of ACLs. So in the ACLs used to define traffic streams, and then you're going to create the ACLs and bind them to the interfaces themselves. Okay, and Iptables is going to be a little bit different. We're going to talk about chains, although it's the same concept. The terminology will be a little bit different. There, we're going to talk about input, output, and forward, I think, chains, if I remember correctly, when we look at that one. So you bind ACLs to interfaces and actions. And then the access control of these ACLs is still governed by source address, destination address, the protocol, source port, destination port. So the actions, we will see this quite a bit, as in ASA, Iptables, and in software. Basically, the packets flowing through a firewall can have one of three outcomes. They can be accepted, which is basically permitted through the firewall. They can be dropped, which basically means not allowed through with no indication of failure. So you're just not told anything. Rejected, which means not allowed through, but it's accompanied by an attempt to inform the source that the packet was, in fact, rejected. Okay, so that's the basic idea there. Policies used by the firewall to handle packets are based on several properties of the packets being inspected, including, this information. I've stated that several times. Here's the device. So I haven't updated this. There's the several versions of the PICs. I think you guys have the 515Es here. And then there's the ASAs here, which we have 5510s. And I think we have other models, but I don't remember right now. Okay, but mainly, or the majority of them are the ASAs are 5510s. This command, this is probably not going to work on the ASAs, but just be aware that by default, the firewalls may drop ICMP packets. Okay, so that's why one hint that I'm going to give you guys when you're testing the ASA is actually have a computer. I still have this, right? So have a, here. So when you're testing the device, a lot of you want to ping. So you ping this and you ping that. But sometimes the firewall by default may be dropping ping, may not be allowing ping. So you have to kind of enable that. Another thing that you can do when you're troubleshooting is if you just set up a machine here, and I would recommend that you do this, that you have one VM where you have Apache running on it. So what you can do is if you have a machine that has Apache on it, what does that mean? It is a web browser effectively, right? Port 80 is open, it'll have a website. And so sometimes from client PC 10.0.1.2, instead of pinging and trying to ping something, right? And maybe it's being blocked by the firewall, you can also just open a browser on 10.0.1.2 and try to open 192.168.1.3. And if you open, that is not ping, right? That's gonna be TCP on port 80. So that has nothing to do with the pinging with ICMP packets being dropped by default on the ASA. So that's a good way of troubleshooting and figuring out if ping is the cause, but it requires, as I said, which should be pretty straightforward, have a VM with Apache running on it. Does this make sense? I've noticed some of you having issues with ping, and so that's why I wanted to recommend this, because it's actually a good way of ruling out ICMP, right? So if If you also try web browser and that doesn't work, then certainly there's another problem unrelated to ICMP. Questions? All clear? All right. So these are just, over the years, so common little things that happen a lot. So, all right. So we talked about the devices. Talk about this. Show some of the commands. Show access list. If I remember, show access list. Show access list is the command that shows the hit count, I think. Have you guys heard of the hit count in the device? So the hit count is actually pretty nice. So what you do is when you show access list, right? When you show all the rules in there, there's a little field in there, and that's the hit count. And what that means is it's a counter that every time that you hit a rule, it goes up. And so usually when I'm grading or whatever, I don't even need to see anything else. I'll just say, show me the hit count. So then you'll show me the rule that you have in memory. And then let's say it's an ICMP ping type of a rule. So I'll just ask you, okay, go, it's 0, right? Now ping. And the ping was dropped, but we don't know if it worked or not. But then I'm going to say, show me the hit count. And then if the packet went up, or the counter went up, I know that that traffic that you just sent actually hit that rule because the hit count went up. You guys see that? And that is available in Iptables. It's available here in the ASA. And so it's definitely something that we can take a look at. So the access list command you can use to add a rule. So you can see that here, access list 101, deny TCP, any equal www, or the number itself, port 80. Basically what this says is you have a set of rules, 101, and then now you're saying deny or accept specific protocol, very much like what we did with the sniffing and spoofing labs, where we were just looking at specific areas of the packet. So the any just means the IP and the subnet mask. So this denies internal network to access the internet, for instance. And then the access group is a command that can bind group 101 to a specific interface. So you can see, for instance, access group 101 binding it to inside interface, for instance. So this should be both the specific logic, the pseudocode, if you want to think of it that way, of how you can define access lists and then just connect them to the specific interfaces. Does this make sense, guys? Are there any questions here? Okay. So don't forget those things. Those they'll become useful to you. The hit count in particular, once you start doing the ACLs, will become extremely useful for troubleshooting. Just the last one. And then this part, IP hardening, and that's just turning on services. Here, I like this slide. I would just say, take a look at it. As you can see, it's a more complex network, but you can see it's still the very basic idea. Just like a very busy network, right? With a whole bunch of the internet and then a whole bunch of devices segmenting off. So this might be something to take a look at for inspiration. Okay, just to get a feel for what you can do. Okay, and then this is the command for the route. So I was looking for this. Route outside any, and then the specific IP that you're going to send things to, the gateway. Right, this command should be in the hints document. So I'll in a second go to the hints document just to kind of point out where everything is located. And yeah, that's the last one. So before we look at VPN, let's actually take a look at the hints document. So let me close this one. So we went over ACLs as well. I'm going to leave this one because I want to come back to it and then go back to table of contents. So I'm gonna share the bright space. So we went over these slides. Remember everything that this is one of the key documents, right? Firewall picks hints. As I said, you know, should be pretty consistent for a lot of them. Basically, you should focus in on, I mean, read everything, but this is the configuration for the firewall, you know, more or less how you do the interfaces. This is the network address translation part. You can see the global there. So for instance, global outside ID1, right? And then the range is 192.168.120 to 192.168.1.250. So you define however range you want to do. That create, and then the net mask, of course. That creates the pool, and then you use the Nat command to say from the inside, any means 0, and then this one just means this one. So you're mapping any to that pool. Okay, is this clear for everyone? All right, great. And then here's the route, as I said, that's kind of the last one. Route outside any, send it to 192.168.1.1. So that's the default gateway on this interface. Okay. All right. So hopefully that makes sense. All this is pretty important. And then you have commands like show global, show nat. This is kind of the output that you can take a look at. These are the, I won't go through this. You'll know how to do these routers. So, but there's the commands for that. And then after that, see, this provides some examples now. So hopefully a lot of you are already starting to take a look at this, right? So these are examples of the router itself, okay? So you have, for instance, access list 101, deny TCP, host 10.10.10.2 to host 192.168.1.3, log, and then notice here you say access list 101 permit TCP any. Do you guys see that? And that's just a 101. Why do you think there's two commands here? Why do you think that? Any ideas? Yes, sir. Yes, exactly. Yeah, exactly right. Exactly right. Very good. So once you put in a rule in the firewall, it just doesn't allow anything else, right? So in this case with the router, and also remember that these ACLs are sequential. So you can think of them, that's why they're sometimes called chains, right? Or they're lists. It just, when it hits one, it executes that. So that's why kind of the last one is this command of permit TCP any. Remember, this is the router, so it's not very restrictive, actually. All right, but here you're denying, so in access 101, deny TCP, so you're denying all packets that are TCP, where the packet, the source IP is this one, and the destination is this one. And then also, you have sometimes this feature of logging information, okay? And then once you create the access list, you go to the interface, and now you tie that access list to the interface itself, okay, where you want it to live, basically. That's an example of doing ACLs on the router. And then here's an example of how to do ACLs on the firewall itself. Okay, so you can see there's a few commands, access list, access group. And these are just some of the case questions that are actually on that document I gave you, right, of the question. So make sure you go through that and try out some of these, but there should be, yeah, so here it is, access list and then access group. Okay, same idea. So you add a rule like permit TCP any sequence www, and then that ACL out, you are going to tie it to the inside interface, okay, with access group. And then here you can always just do show access list, and like I said, you can look at the hit count, etc. This one's a little bit more complex, so this just gets into now doing some of the more complex ACL rules, right? but usually they're not complex. I mean, at the end of the day, you can just block services and IP addresses and things like that. All right, so make sure you take a look at this document, okay? Oh, here's an example of the hit count, actually. So you can see the hit count, you know, that's that counter that's going to go up. So this should be something that you should, you know, find and explore, because it'll help you a lot with debugging. All right, so I kind of wanted to just point out all the documentation. Let me plug in my. Okay, so that's the documentation that is on there with the ASA. Okay, so we've covered all this. I'm happy with that. Let's go to. So actually, this document then it's covered now. I'm just going to move it here. Right. So right after intrusion detection, we have now covered hints and the slides. Okay, the next one is the practical questions. Okay, so you should all be seeing bright space here. I think. All right, and this is the ASA ACLs. We just covered this one, right? This is the domains of trust, I think. Yeah, domains of trust and the ACL. So we've covered that document as well. And then there's some miscellaneous things and VLANs, although these VLANs are not required for this project, but I saw actually a lot of you were doing that, so that's great. And then here you have some documentation for that. What's important, remember, what I will be doing for the semester is I will be going, I'll be using this for your grading, okay? So it's not that you have to do everything, but in here, you can see is the ASA, build a network, and then basically kind of walk through these scenarios. I think if you just walk through these scenarios and know how to do them, you should be good. Sometimes I may change a service here and there, that kind of thing. One thing I still need to talk about, of course, is this. This is kind of all related to VPN services. And then a lot of these things I've talked about, sniffing and spoofing, logging with syslog, although that's not a required thing. IDS we've talked about, Squid we talked about today. Firewall evasion we have not talked about yet. That will be an upcoming lab. Network attacks we did cover already. The network tap, you all know how to use the tap, correct? You're aware that it's there and just, you know, play with it a little bit, but I think I've talked about it. And then there's VPN, which is what I need to talk about, which is the next topic. So this should be, so make sure, as I said, this document, I think, if you understand everything on that document, then you should be good for your demo. So that one, ACL practical questions, is also at this point covered. So I'm just going to go ahead. And move it. Yeah, so there. Oh, sorry. So that topic is covered, and then that leaves ASA radius and Active Directory, which is these are not documents. You know, I know it says 2012. I'm not saying you're going to use 2012, right? You get that, right? So it just means these are documents that I have saved over the years that I thought were actually pretty good, very well documented. And so what you can do with these documents is read through them to give you an insight into what needs to happen, right? Because it hasn't changed completely, right? It's changed somewhat, but so don't use these as tutorials. Use them instead as just, you know, information, general information. So I believe this VPN Design Security is the document I currently have. Which is what I will talk about now. Notice VPN client, Cisco, don't use this VPN client. I don't think it'll work on Windows 10, which is what most of you are using at this time. So you will need to find a solution for this. And the problem with these things is, you know, as I said, the license and all that, they monetize this, right? So you will need a server, Windows Server VM. Can you guys get that still? You used to be able to get VMs for that. Do I need to ask Donna to give me one of those, or are you guys able of getting? Okay. Windows Server. And okay, all right. Yeah. So my point is you will need to get Windows Server, okay? Because that's the best way to do Active Directory services for VPN to work, okay? And so I'll talk a little bit about the scenario that we usually have done every year for that. All right, so let me go back to Brightspace over here. So those are the documents. As I said, there's one document here. If you look, just read through it. It talks basically about setting up Active Directory. And what that means is, you know, spinning up this Windows server and then some of the configurations of it. Setting up Radius service. Radius is another service, right? But Radius can be a Linux. There's something called Open Radius or whatever. But actually, the Windows server, the Microsoft Windows server, has both services: Active Directory services and Radius services. They're just two services that need to be running on Windows server. You guys see that? And so, you know, we'll define this in a second, but you might need these two services to get up your authentication, basically, running for something like VPN. All right. So anyway, so we'll take a look at the slides in a sec. So let me go back to the table of contents here. You guys should be seeing the table of contents. So that's this one. So all these documents are at this point assigned to you. All right. So read through them. Again, these are not tutorials for you to use 2012. They're only good documents that I think provide some good insights. You can just get a blog post online as well. All right, so here is the, so these three. So at this point, I have now covered, or I'm done with ASA, these modules, so you can take a look at them. As I said, we'll probably do the seed firewall next at some point. And then Iptables is much more involved because it involves hardware and involves the Raspberries. So, and the taps. So this one, and it's actually, there's a lot of problems. This one is it's more work, I think, than this one. So we'll save this for after spring break. Okay. And then software VPN. Oh yeah, that's software VPN. Needs to happen at some point. So let me just leave it there. Probably last because it's CC++, and I know you guys love CC++. Right? So, but it's all the code I've given you, and I basically will just point where you need to write those things. All right, so that just leaves for the rest of class today is just to talk about VPN services. Okay, so let's go ahead to the slides. So this is called VPN Design Considerations. I think it's the same document. I think I just downloaded this twice. Yeah. All right, so I'll close one of these. All right, so let's go ahead and okay, and let me share the screen for that one. So there's a couple of challenges with this one. So we'll have to think about it a little bit. So VPN Design Consideration. So all of you have used VPN at some point or another, right? Who can tell me what is VPN? Okay, virtual private network. And what does that do? An encrypted tunnel for your traffic, right? So that you can connect from anywhere in the world to a more secure or domain of trust, right? A more trusted environment, usually an internal network. Okay, you want to connect to an internal network. So that's the last part of the project this semester. Depending on how you see it, could be the easiest or the hardest. Okay, because there's a few. The problem with this one is there's a lot of moving parts, right? There's a lot of things involved here for this to work. I only ask one question, usually with VPN. It's very simple. I will say, go to switch 3. Do I have the? Let me see if I have. I don't have it. Okay, but you guys know the basic network, right? So I'll say go to switch 3, connect a computer there, a laptop, in switch 3, open VPN client. Now in switch 1, which is in the internal network, you're going to have some kind of a server like Apache, right? And you have a website there. That website cannot be accessed from the outside. What I will say is, I want to see the files in that web server, but you're outside. Do you guys see that? Additionally to that, I'm going to say, create an account. And I'm going to make up some name, right? And then you're going to create an account. And then when you log in from the outside via VPN client, you usually use that account and you get authenticated with that. Do you see that? And that's where the Active Directory comes in, because Active Directory is the one that allows you to create accounts and authenticate to it via VPN. All right, so that's the idea. So hopefully that makes sense. So VPN Design Considerations. The basic foundation is identity concepts. Okay, so this is authentication. Most basic when you have identity concepts is application support ID and password. So, but also we have public and private key authentication and the whole idea of managing keys. However, for our example, we will only be using username and password. Okay, so this will be a higher level of authentication beyond MAC address, but it'll be a user identity. Now, this involves identity technologies, all right? So the common name for these technologies is AAA, which basically means authentication of authorization and accounting. So Radius services usually provide this concept, right? So you will have, for instance, a connection to the firewall via VPN. So you're going to be coming in on that protocol, on that port of the firewall. The firewall will then go through Radius services, right? Which is what you're going to configure that service on the Windows server, okay? And that's going to have some access control related to the firewall, allowing access into the inside network. But additionally, because you're coming in with a username and password, you're going to have to connect to Active Directory services. And Active Directory services are where the account is going to be set up so that you can authenticate to Active Directory and then also gain an IP inside the network. Do you all see that? Does that make sense? All right, so that's the idea. So this is AAA services like Radius are concerned with verifying the user and or device. You're going to do some authentication. Now you can, in fact, authenticate on Radius itself. You could set up an account there, and that's something that could work. And I would recommend probably that you start there, but just to make it more fun, you can authenticate through Radius, but say to Radius, by the way, user accounts are managed centrally through Active Directory itself. Do you guys see that? So that's really the key there, right? So that, we're assuming that you're managing centrally through Active Directory. Okay. And then there's other ways of authentication, of course. So the two protocols for AAA, Radius and Calix, right? So protocols, these are protocols, basically, implementations. As I said, Linux has Open Radius or free Radius, but we're just going to use the Windows server. That's what makes it a lot easier, way easier. the documents that I showed you a second ago, all of those basically provide a very nice description of all of those ideas. Okay, so certainly read those documents. You know, they're work done by students like yourselves in past semesters, and they're very detailed, right? They're going to speak to you because it's really the same problem that they were trying to solve. Okay, so definitely take a read through those. These are protocols with centralized authentication for a network. A server in your network contains a database basically of usernames, passwords, and access rights. When user authenticates to a device that uses Radius, the device sends login information to the central server, and a response from the server determines whether the user is granted access or not. And that's basically what's going to happen. You're going to come in from the outside of the firewall. You're going to hit the outside interface, and the outside interface, because it uses the outside interface or the ASA, let's say, it's going to be configured to use Radius. So then it's going to look for the IP of the Radius server, which in this case should be the IP of the domain controller. So the device sends login information to that central server, and then a response from that server will determine granting access. Radius will be configured to access Active Directory services to check if that account and that password are valid. Does that make sense, guys? How that should work? Are there any questions about that? Nope, pretty easy. All right, so anyway, centralized services contain usernames and passwords. Radius servers are commonly called AAA servers. And, you know, obviously, as I said, because of authentication, authorization. Cisco has used this name in the past, and Radius is just the open standard. And I think on Windows Server, it's actually referred to as Radius as well. So this we've talked about. Where do you deploy your AAA server? AAA server is master repository of all credentials, probably on the inside network, is what I would recommend. It can talk to the domain controller where you can add users to the network. Actually, it's going to be the same device. Active Directory is what is called a directory service. It stores objects like users and computers. Okay, and so you will, as I said, on the fly when you do your demo, you'll have to create an account in Active Directory, and then you should be able to connect. So a domain controller is what the server running Active Directory and Radius is called, right? So your Windows server and so on. So root AAA topology, all of these devices can connect to this type Radius server, right? So you have like security devices like the ASA, administrative devices, firewalls, wireless LANs, VPN servers, where VPN servers could be their own devices, like OpenVPN, etc. But we are not, we're just going to use the built-in services, okay? Once again, firmware is going to be really important for this. In the past, actually, we have had to get the firmware and flash some of those devices because sometimes they don't come with the GUI interface. They only, the firmware may only have, I think in the past, they actually had two firmwares in there. One for the command line, the CLI that you've been seeing, and then the GUI interface. So this is yet another thing to start researching for your, you know, if you're using the PIX or the ASA 5510, make sure that you start, it should be called ADSM. Make sure you start looking to see if that firmware is already installed, what version it is, and then hopefully I'll talk about a sequence of commands that should help you to get started with that. I hope it's not Java for some of you, it's definitely Java. All right. Anyway, so that's this idea. And then the ASAs can talk to other devices like one-time passwords, OTPs, right? And also like Active Directory services, etc. For us, we'll just use one device. Okay. Yeah, so we'll use the firewall to do this. Oh, yeah, the firewall actually, usually you can actually set up an account on the firewall. So what that means is you don't even have to talk to the domain controller. You could actually sometimes just set up accounts there and do the authentication on site. That might be actually a good way to start with testing VPN. Just set it up there before you actually go into, because it's very true that configuring Windows Server will take some time. Okay, you have to configure a couple of services, etc. But at least that's the last of it. So I definitely at this point in the semester, I usually like to start pointing out that you need to start thinking about this as well. Okay, so I think, and then, oh yeah, VPN. So let's talk a little bit about it. VPN means to establish a private network over any other network, usually traverse the internet. The other network is deemed insecure, as you know, so we need to provide security. So it's a tunnel with cryptography. Okay, you can see that here. Basically, simple scenario. You encrypt your traffic, right? And then on here, it's going to be decrypted so that it can get access. So there needs to be an agreed protocol between the firewall and the laptop here. So remember, there's going to be a VPN server and a VPN client. Okay, so that client it's an issue. Okay, so we need to start getting that's compatible with the firewall that we have here, the ASA or the PIS. Okay, so those are definitely things to consider. Okay, the crypto, basically, I think, as you know, from 350, you remember that when you encrypt something, it's actually slower, right? It's going to affect performance. So that's really why I have this in here, to remind you of that. The protocols, you can play with them. You're probably going to have AES, right? For those of you with the 5510s, I would assume is AES for the symmetric encryption, and then some kind of public-private key with RSA. And then there's going to be the hash functions, probably SHA-256. I think you can select the individual protocols. You guys know about the algorithm, so that should not be an issue. And you can just use the defaults, to be honest. All right, so there's a couple of types of VPN services. There is client-to-site VPN and site-to-site VPN. For this class, you only need to set up client-to-site VPN, which basically that's the one where you have a laptop with VPN client, and then that's the client, and then to site, that's the ASA with VPN server. So that's client-to-site VPN. Site-to-site VPN would be if in this classroom we have an ASA, and in that classroom we have an ASA, and the two ASAs are already configured to kind of be connected through a secure tunnel. So any traffic now via routes, right? I want to access the web server, but it's over there. Well, I'm going to put in that IP address. It's going to go here, right, to the default gateway, but there's a secure tunnel, so it's going to arrive at the other one, and then you'll be able to access those devices. So the configuration is done from ASA to ASA. You need two ASAs. So for those of you that are brave, you can do that if you want, but you need to find another group. You guys see that? So if you want to try site-to-site VPN, I'm not going to stop you, right? I'm also not going to ask you to demo it. So, but if you want to show in the class or something, that's perfectly fine. Just be aware, you probably need to have another group to kind of work with them, and you have to make all the connections, right? So you have to, build a network. And then just do but it should now, the advantage though, if you use the ADSM, is that it's all like with wizards. Like, the GUI interface has wizards usually for the configuration with a lot of default values, and then it makes it a lot easier. So the site-to-site VPN is usually, what time is it? All right, so we'll wrap up. So the site-to-site VPN, also known as LAN-to-LAN or gateway-to-gateway. Advantages: all communications are encrypted and authenticated before they enter the other network. You don't have, you're just basically like your two sites become one, basically. All right, you can see the scenario here. This is an ASA, this is another ASA, right? And so they're just connected to each other, basically, and you build the network there. Remote user VPN, or the client to site VPN, also known as remote access or host to gateway. Easiest method, the one you'll do in this class. Remote software client, you need that one, that resides on the remote host, and it can be inexpensive, hopefully, and convenient. This is where, the classic example is the laptop, right? The mobile worker, which we, nowadays everyone's a mobile worker, right? That's the new paradigm. So you have here a laptop, and then the laptop connects to the environment at work, etc., the main office. And then this, you guys know the cryptography aspects. And then, let's skip that. Oh, the last thing I want to say is I want to point out, as I've said many times, with the ASA or the PICs, with the firewall and VPN, you could configure through the terminal or PDM or ADSM, whatever it's called now. But it's the Gui interface that is, so you need a browser. It's kind of a web thing. This is an old picture, but it is web-based. We need a manager PC in the inside network. Usually to do this, you actually need to add a rule that says this IP machine outside can actually connect to us. Okay, it will connect via web browser. Then we can configure everything on the device, although we're only going to use it for VPN in this case. And then on the manager will be some kind of a VM you will need to add, and then this disregard. And then, these are the commands. So on the device, you need to enable HTTP, and also then give permission to the manager to connect. And then start the service for PDM. And then it'll, something like this, right? So the key thing is you'll have some wizards there that will allow you to set up things more easily. Use the wizard to configure. And then I've talked about all this. All right, that's it. So that's basically it. That concludes my slides on ASA. You have all the materials. Hopefully this provides you some good guidance of what you need to do. And just be mindful that depending on your version, that the commands are going to change a little bit. One key thing that I would highly recommend starting this Thursday is try to reach that GUI interface. Because if you don't have it, we're going to have to get it right and flash it on there. Which I'm hoping that's not the case for some of the devices, for any device, but you need to check for sure. Okay. That's it. So that's basically it for today. So I'm gonna stop the recording.